Here we go. This section is about two more kinds of proofs. I'm going to say this a couple of times today during this class period. The only proofs that we are going to write this school year are two-column proofs. You get to the homework and the homework says, write a paragraph proof. You're going to say, nope, Lashley said write a two-column proof. And you're going to write a two-column proof. If you get to the homework and it says write a flowchart proof, you're going to say, nope, Lashley said write a two-column proof. You're going to write a two-column proof.
Wait, if we're going to write two-column proofs, why would
So, good question. As you progress through mathematics, you are going to have textbooks and classes where you're going to see proofs in various forms. So I want you to recognize the different forms. We're going to talk about what they look like, how they compare. Your homework today is going to be simply taking a flowchart proof and writing it as a two-column proof. So you won't even have to come up with the statements and the reasons. You're just going to organize it different. Same with paragraph proofs. I want to show you what they look like, but then when you get to the homework, you're going to be taking a paragraph proof and just rewriting it as a two-column proof. So I want you to be exposed because you're going to have a lot of paragraph proofs in different textbooks. That's something that's very common. Obviously, I don't like teaching English and writing. I teach math, so I don't like to grade paragraph proofs because it's this big, long, run-on explanation versus nice and neat and organized columns. So we're going to focus on two columns because I want us to get good at one kind of proof. Okay? Edwin, do you have a question? Okay. So the other thing that's important in this section is not just understanding the difference here, but there are a couple theorems in this section that we need to learn as well. Okay? All right. So like I said, basically today, all you're going to have to do is understand vocabulary-wise what is a flowchart proof, and then take it and write it as a two-column proof. So if you've ever seen a flowchart, flowcharts typically have some sort of information maybe in a box, and then they have an arrow that points to some other different information that's in a box, and then there's an arrow maybe that points over to some more information in a box. Do you guys know what I'm talking about with the flowchart? Your proofs are going to be just like that if they're in flowchart form. In a flowchart proof, you're going to use boxes and arrows to show the structure. Here's the thing. Your statements are going to be written in the boxes. So the reasons or justifications are going to be written below the box. So the way it'll look is you'll have a statement in the box, and then below the box will be a reason. Does that make sense? Okay. What I love about a flowchart proof is it makes you show the connection. So in other words, this statement I knew without having to know anything else above it. But to get to this statement, I had to know this one, and it came from that statement. You'll have problems where there'll be maybe another statement over here where you didn't need anything else to state it. Maybe it was given, or maybe it came from the picture. But then you might have this statement and this statement connect to make this one. Maybe you substituted whatever you had here into this statement to get this one. So it shows your thought process. Which ones did you have to connect together? In a two-column proof, that doesn't happen. You just have all these things listed, and you might have used numbers 2 and 5 to get number 6, but you didn't have to show that you used 2 and 5. Does that make sense? So I really like the flowchart proof for that reason, because it really makes you think, how do I connect these objects? Okay, so that's a flowchart proof. We'll get to paragraph proof in a minute. Before we do, this is a theorem that we need to talk about. This is not one that we use a lot in proofs. This is one that you're going to use more in a picture where you're trying to solve a problem algebraically. Okay, common segments theorem says if you're given collinear points, A, B, C, and D. So collinear again means on the same line. So notice A, B, C, and D are all on the same line. If they are arranged so that AB is congruent to CD, notice the tick marks, AB is congruent to CD, then if this is our line segment arranged so that these two little pieces are congruent, then AC will have to be congruent to BD. Think about why that is. AB is congruent to CD, and what's the other part that they share? BC. Notice that BC is the other part that's connected to AB to get AC, and BC is the other part connected to CD to get BD. So since they share that common piece in the middle, common segment, they share this common piece in the middle, and the other little parts are congruent, then does it make sense that these parts would have to be congruent? In other words, throw in some numbers. If this is 5, what does this have to be? 5. And let's just say that this is 10. So what is AC? 15. What is BD? 15. Because if their little pieces are congruent and the part in the middle they share, it's congruent to itself, then your part plus your part is going to equal your part plus your part. Okay? It's called the common segments theorem. It's called common segments because they share a common segment. And then if the other parts that are not common are congruent, it makes those pieces added together congruent. So where you could use this in a proof, you won't use it much in a proof, but if you did, this could be a statement. So maybe they give you AB is congruent to CD and they give you this picture. Your next statement could be that AC is congruent to BD. And your reason would be the common segments theorem. And this would be the reason for step 2. More often though, what you're going to see is a question on your homework where they're just simply asking you to find maybe the length of this. And they give you information as far as numbers, and you just have to use the idea to figure out what are the measurements, okay? Just like I asked you, what was this length? And you said 15. And what was this length? And you said 15. It may be asking you, it may give you that these are 15 and ask you, what does this have to be? And then you would say 10. So it's mainly going to be just used in solving a problem, okay? Any questions there? All right. Okay, so here is an example of a flowchart proof. Notice all the boxes and the arrows. When you write a 2-column proof, which is what your goal is going to be today, is to basically just transform this into 2 columns. So I should have given you an empty box that says statements and reasons already so that we can write this out. First of all, how many statements in that flowchart proof could be written first? 2 of them. There are 2 statements that stand alone that have nothing above them, right? Which means they don't depend on anything else. So you could either write this as statement 1 or you could write this as statement 1, and it will not matter. What does matter is where you go next in your proof, okay? And that's when you follow the arrows. So we'll do this one together. I'll write it on the board. Do you guys want to start on the left or on the right? So you want to start over here with angle 1 is congruent to angle 3 given? Okay, so we're going to do number 1. Angle 1 is congruent to angle 3 given. Okay, at this point you have 2 options of where you want to go. You can either go down with your arrow and write this next statement because it comes from that given, or you can come over here and write the other given. What would you rather do? Down. That's what I would do because it helps us think logically. We knew this. What did that let us conclude? And guys, as you're writing these, watch what you're writing. What is the statement saying? What's the reason? And let that help you think about how you could write this proof if you had to write it. Okay? So number 2, notice they said, well, if they're congruent, that means they are equal. And the reason we know that is because why? Definition of congruence. Do not abbreviate when you do your homework. Even if they abbreviate, you're going to write it out. You can put definition of congruent or definition of congruent angles. That's what that little symbol there is. It doesn't matter to me. You can. I usually write it like this, angles, apostrophe S. They write it like this with an S inside. It doesn't matter. And I would accept just definition of congruent. Okay? So now, where do we have to go next? Okay, we can't go down here. Why can't we go down? Okay, because we have to have this both joining in together to get this next one. So we have to go back over here to the left now and start with this other given. Does that make sense? Okay. So number 3. They give us that angle 2 and angle 3 are complementary. And again, the reason underneath is given. Where do we have to go next? Down. Again, we can't go to the right yet because we haven't figured out this next statement. And notice what they said next. If they're complementary, then that means they add to equal 90 degrees. So the measure of angle 2 plus the measure of angle 3 equals 90. And the reason is definition of complementary. Make sure you're spelling complementary correctly. I've got a couple of you spelling it with an I. There's not an I in this kind of complementary. So be careful you're not giving compliments. It is complementary. Okay, where do we go next? To the right. It took both our second statement and our fourth statement together to get this next statement. And notice what did they use as their reason? Substitution. So look what they did. Instead of saying 2 plus 3 equals 90, they replaced angle 3 with angle 1 because 1 was equal to 3. Does that make sense? And the more we can follow those proofs, the more it'll help us when we're writing them on our own. So number 5, measure angle 2 plus measure angle 1 equals 90. Be careful that you complete the reason. They abbreviated, and you don't just put substitution. What do you also include? Property of equality. So even though they are abbreviating, you're not going to. Okay, so be careful. And then obviously our last step is just to go straight down. Number 6, angles 2 and angle 1 are complementary. And once again, remember that those definitions are biconditional. They go both directions. So if they're add to be 90, then they're complementary. And vice versa. If they're complementary, then they add to be 90. So it can go both directions. Easy? So today we are just taking a flowchart proof and rewriting it into 2 columns. Well, that and paragraph proofs, but yes. Same thing. So there could be a question on the test that says, here's a flowchart proof, write it as a 2-column proof. We're just rewriting it. You are not writing your own today, okay? So today is just understanding there's a different format it could look like, but practicing putting it into our format 2-column. And if you have any questions, anytime throughout the entire semester that say write a paragraph proof or write a flowchart proof, you're going to say, nope, Lashley said 2 columns. Okay? All right, any questions here? All right, moving on. Okay, so here's another example. Instead of writing this out and taking the time, can we just put beside them like S1, R1 for statement 1, reason 1, and go through it a little quicker? Okay, so when I look at this flowchart proof, first thing is what are my options for where I could start? Okay, I could start on the left. I could start somewhere else. On the right, because notice neither one of these have anything leading to them. So both of them could be your statement number 1. This one is given to you. Where does this come from? The picture. So you look at the picture and you go, oh, wait a minute, RS plus ST equals RT. That is using the segment addition postulate for just that piece of the picture. So you can get that from the picture even though it wasn't given, and it doesn't depend on anything else. So it doesn't matter. You could start either location. Is that clear? Okay, 95 or 99, whatever I said the other day, % of the time, the given comes first, but it doesn't have to. Okay, so this is one where you could start with segment addition postulate, right? Okay, but I'll go ahead and start over here on the left. This is statement 1 then. So then reason 1 would be given. Is it okay if we just do that? Now in the homework, you have to write it in 2 columns. Okay. Now, what are our 2 options of where we could go next? We could go to the right, or we could go down. Okay, so from this, they say use the addition property of equality. Let's understand what they've added. They said RS equals UV. RS equals UV. But then they added ST to the left, and they added something different to the right, which is a little confusing. But notice what they said about ST and TU. They were the same. So if they added ST to the left and they added TU to the right, they still really added the same distance to both sides of the equation. Does that make sense? Okay, even though they're different names, this means the distance from S to T, and it's the same as the distance from T to U, so it's really adding the same thing to both sides. Okay, so we could go here next. This would be statement 2, reason 2. But then we have to go where next? To the top right, because we can't say this RT equals TV until after we have the angle or the segment addition postulate. So this would be statement 3. This would be reason 3, and we just said that came from the picture. So let's follow what they did here with substitution. Notice what we did. Where we had RS plus ST, that was equal to RT, so they substituted RT in over here on the left. And where we had TU plus UV, that was equal to PV, so they substituted TV over to the right. Does everybody see their substitution? Okay, so then that leaves us with statement 4 and reason 4. And again, we would put substitution property of equality. And then if two things are equal, that means they are also congruent by the definition of congruent. And you can put congruent segments like we had congruent angles, or you can just put definition of congruent. I'm okay either way. Questions there? Okay. So I'm hoping this feels pretty easy, but I also want you to think again, as you're writing it down, how did they get what they got to help you practice for proofs? Any questions on flowcharts? All right. Again, flowchart's probably my most favorite, but 2-column is what's most used, and so we're going to practice 2-column. Okay, paragraph proof is my least favorite because it's a lot of writing in sentences, and that's not my favorite thing to grade. A paragraph proof is simply a proof that presents the steps of the proof and their reasons in a paragraph as sentences. So let's don't miss that on the vocab test. A paragraph proof presents its statements and reasons in a paragraph, okay? Should be pretty easy. Okay? Yes, ma'am.
How long do the paragraphs get?
So they can get extremely long if you have a long proof. You have to list every statement and every reason together in a sentence format. It's not hard to write a paragraph proof, but there's just a lot of extra things you have to add to make your sentences grammatically correct and punctuation and all of that. It is sometimes a little less formal than a 2-column proof, because sometimes they'll combine some things and say it's by the same reason, and so it sometimes gets a little less formal. Okay? So let's look at some examples, but before we get there, a couple more theorems. The first one we already learned. This is the theorem that we put back in chapter 1. We had to add it to our notes because it was needed on the homework, but they don't teach it until here. This is extremely important, and you will use it all of the time this semester. Vertical angle theorem simply says vertical angles are congruent. So if you have a proof, one of your statements says you've got 2 angles that are vertical, your next statement could be that those 2 angles are congruent, and this would be your reason for that statement. Okay? All vertical angle pairs are going to be congruent. Okay, the next one. This one, it's not used a lot until it's used, and then it's important, and you will use it. So the bad thing about it is it doesn't have a name. The good thing about it is you don't have a name to memorize. You just need to know what it says, and then you can put that in your own words when you're in a proof. But it takes a while to write it out. So here's what it says. If 2 congruent angles are supplementary, think about that. 2 congruent angles are also supplementary. What does that mean? They have to add to equal 180. Okay, if they have to add to be 180, but they're congruent angles. What does that mean each angle has to be? 90 degrees. So what this lets you do is skip a couple steps. It says if you have in a proof somewhere as a statement that angles 1 and 2 are congruent, probably in a different statement you're going to have that 1 and 2 are also supplementary. So if you have congruent angles that are also supplementary, you can conclude right away that that means they are right angles. You don't have to say that their measures add to be 180. You don't have to solve to get that they're 90. You don't have to use the definition of a right angle to say that if it's 90, it's a right angle. You can go straight to if they're congruent and they're supplementary, they are right angles. Okay? The reason would be this sentence, and you would have to write it out, but basically all you're saying is congruent angles that are also supplementary form right angles. And that's all you have to say. And you can put it in your own words as long as you include those 3 important pieces of information. Then they form a right angle. It doesn't have a name. I don't know. So, yeah. You can use this shortcut notation, but you may not remember that. If you want to use it, though, on the homework, you're welcome to. It says congruent angles that are supplementary implies you have right angles. Okay? So you can use that shortcut. You would need to write out the word supplementary. Congruent angles, supplementary, implies right angles. So if you could do that in a proof, okay? Or you can just say, 2 congruent angles that are also supplementary form right angles. Okay? However is better for you. But this would be your reason for your statement number 3. This would be your reason for that. Any questions? It is just a shortcut. If you didn't remember this, you could go through and use the definition for supplementary, change this to equality, do some substitution, solve to get that you have 90-degree angles, and then eventually get that if they're 90, they are right angles. But it would take several steps in a proof. So it's a little faster to do it this way. I told you it's short today. Okay, so again, the only goal today, last example, correct? The only goal today is to be able to take a flowchart proof or a paragraph proof and rewrite it as a 2-column proof. Okay? And then you might have some problems that use that common segments theorem or that use that idea that if 2 angles are congruent and supplementary that they form right angles that are not proofs. There may be a few problems that are just math. Okay, so here is a paragraph proof. Let's look at how it looks. Notice it's in complete sentences. There are periods. There's capitalization. Your goal is to go through and pick out the statement and the reason and write it in 2 columns. So read your first sentence. It is given that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. What's the statement? What in your 2 columns? What's your statement? Okay, so this is going to be our statement. Number 1, what's going to be our reason? Careful, your reason is just given. Okay, I'm going to go ahead and write this one out on the board with you, just to practice. Say it again. It gives you everything in the paragraph proof that you need. All you're doing, yes, it has to be in order or your paragraph proof is not correct. You have to organize it into 2 columns. Okay? Hold on, let me write this one down first. Measure angle 1 plus measure angle 2 equals measure angle 4, and the reason was given. Okay? Go ahead. Edwin, what did you say?
So the next one would be angle 3, 4.
Okay? So the statement would be angles 3 and 4 are supplementary. So that's going to be our statement 2. What's going to be the reason? Linear pair theorem. So we're going to come over here, statement number 2. No, it has to be exactly, because be careful, and this is very important, Ridley. Everybody listen. The linear pair theorem does not say anything about adding to equal 180. The linear pair theorem says that they are supplementary. What tells us that that means they add to be 180? Definition of supplementary. And that's where, in our pre-AP minds, we want to just combine steps, but we have to, in a proof, list everything separately. Okay? So angle 3 and angle 4 are supplementary. And again, the reason was linear pair theorem. We will use that a lot as well, so this is a really good example of practicing using that theorem. How did they know that? It wasn't given. So where did they get that from? The picture. If you look at the picture, do you notice that 3 and 4 form a straight line? Okay, if we were writing this proof, I would make you put a step in between 1 and 2 that says angle 3 and angle 4 are a linear pair. And the reason would be definition of linear pair comes from the picture. They're adjacent and they form a straight line. Since they wrote the proof and all we're doing is rewriting it, organizing it, then I'll not expect you to show that step. But if we were writing it, we would include they're a linear pair. Because they're a linear pair, that means they're supplementary. Because they're supplementary, that means... So the next statement would be 3 plus 4 equals 180. So statement 3. And the reason? Definition of supplementary. Notice what they wrote, though. They just put by definition because they're referring back to the word up above, supplementary. You're going to have to know, what are they talking about? Which definition? So be really careful, okay? So number 3, measure of angle 3 plus measure of angle 4 equals 180. Definition of supplementary. And then what's next? Substitution is going to be our reason. What's our statement? Okay, so measure of all of this is equal to 180. That's our last statement 4. And the reason? Substitution, property of equality. So again, this will be reason 4. This was reason 3. You've got to fill in some of those missing words that they're not putting. That's the only thing to be careful about. So number 4 would be substitution, property of equality. And the 4th statement was measure angle 3 plus measure angle 1 plus measure angle 2 equals 180. Questions? Would you agree this is pretty easy? Okay. No. Here is the thing. Here is the thing, though, guys. When we get to the test on Friday, nobody should have a blank proof. What is always the first thing you can at least write down? The given. And what is your last statement always going to be? What they told you to prove. I should not see any proofs on Friday that are blank. Okay? So, if you don't know, you should at least write those things down. I will be giving you points for having a 2-column proof, statements and reasons labeled at the top, that you have listed your given, that you have listed what you were trying to prove, and you'll get points for the middle part. But if you at least write down the given on this first test, I will give you points for at least having your given, okay? So every step is going to have a point value, all right? Now, as we get further along, I may not give you points for the given. It may be for more of what's the meat of your proof, but right now we're just learning. So no blank proofs on Friday, right? Okay, because I'm probably going to yell at you if you turn in your test with a blank proof. Okay.